Hello mathematicians! So today we're going to look at 7.1 and 7.2, the first section of Unit 7, which is on graphing exponential growth and decay models. What you're going to want to have on you. Those guided notes that I handed you, definitely going to want a calculator, and then a pen or a pencil today. So, what would you rather have? Would you rather have $10,000 given to you every day for the next 30 days? Or would you want a penny today, but it'll double every time or every day for the next 30 days? Well, a lot of you are thinking, whoa, I'm pretty sure I want A. That's a lot more money, right? Actually, if you work it out, you will get more money with a penny today. You're going to double it every day. You're actually going to get a lot more money faster. So, that's what we're talking about. Exponential growth and decay. Now, you've heard about exponential growth and decay. Your bank account, that's exponential growth. It grows by exponential percents, and we'll talk about that in our next video. Population, you've heard about population growth. Uranium decline, you've heard of that. Your uranium can break down so fast. Depreciation of your car, you've heard that a car, if you drive it off the lot, you lose value. That's exponential decay, also by years. And then carbon dating. You've heard about carbon dating before. You talk about it in science class a lot. That's how they figure out how old a mummy is. So, here's the two kinds of graphs we're going to be looking at. This over here, this is a growth graph right here. And this is a decay graph. Notice how the decay looks like it's decaying. The growth looks like it's growing. So kind of keep that in the back of your head. When you're doing a growth graph, it should look like it's going up. Decay should look like it's going down. So be careful of that. Here's some goals. You're going to want to be able to graph exponential growth and decay graphs. You're going to want to be able to identify the domain and range. And we're also going to talk about asymptotes. So what the heck are those, you're saying, but we'll figure them out. And then we're going to identify them on our graphs. So the exponential model. This is what you're going to see a majority of the time. However, A and B are going to usually be numbers. So exponential growth function, if B is greater than 1. So if my B right here, if he's greater than 1, you have a growth function. It's going to go up. So it's going to be a graph that looks something like that. And that the B then is called your growth factor. It's how much it's growing by each time. Exponential decay is when you have a fraction or a decimal. 0 through 1. So it has to be less than 1 but greater than 0. No negatives here. So this is going to be a graph that looks something like that. Goes down. Decay factor is if you have a decay function, then your B is your decay factor. So let's just jump in. Let's try to graph this. So, very first thing, to know what you're going to put in the middle, you're going to want to look at your exponent here, wherever the x is. And you're going to want to think, set that equal to 0. Like that. So x equals 0, so my x is just going to be 0. Then let's fill out the rest of our table. So I got -2, -1, 0, 1, and 2. Wonderful. Now, this is when our calculator is going to become exceptionally important. So 3 times 2 to the -2. I'll wait for you here. Wait for you to type it into your calculator. That's, you should have gotten, I'm hoping, 0.75. If not, do a double check. Make sure you didn't type it in wrong. -1, you should have gotten 1.5. 0, that's 3. 1 is 6, and 2 is 12. Wonderful. So now let's graph those points. -2 is 0.5, so we're going to have 1 right there. -1, 1.5, that's going to go right there. 0, 3, it's going to go right there. 1, 6 is going to go right there. And 2, 12, oh, that's just going to be somewhere up there. So this graph is going to look something like this. Alright, so now, Here's that silly word again, asymptote. Asymptotes are very fancy. It's a very fancy word for a line that the graph cannot cross. Asymptotes cannot be crossed by the graph. Period. End of story. So I always look at my graph here, and I start looking and thinking to myself, what number, or where does my line starting to not cross? Well, it doesn't look like it's crossing right here, right? 0, 0, or over the 0 line. Even better, if you would start plugging in -3, -4, -5, you would notice it's getting very close to 1, 0, but it's never touching 0. So the equation of that line, change back to my red here, y equals 0. That's my blue line. And notice how I actually highlighted the asymptote. I find it's easier to highlight it. That way I don't cross it with my graph. I will be very picky. If your graph crosses your asymptote, technically you are wrong. So be very, very careful. Make sure that you don't cross it. Your domain is always going to be all reals. So it's going to be that fancy R that we've been writing. And our range, notice, I don't have any y's greater than 0. Not equal to, can't be equal to 0, just greater than 0. So, what's an asymptote? Here's the actual formal definition. An asymptote is a line that a graph approaches more and more closely, but never truly crosses nor touches it. So here is my graph here. So my asymptote is right there at -3. So this would be y equals -3 for that one. So your asymptote is where the line or your graph doesn't actually cross it. It never crosses that area. So you're always going to want to watch for where that is. So let's look at this one. First things first, let's figure out what number is going to go in the middle here. So I'm going to look up here, x minus 3. I need to figure out what do I need for x that would give me 0 there. Oh, that'll be 3, right? So I'm going to put a 3 there, fill out the rest. 3, 4, 5. There we go. If you would plug these into your calculator, you should get the following. -4.75. -4.5. -4. -3. And -1. So let's graph those. 1, -4.5. 2, 4.5. 3, -4. 4, -3. 5, -1. So it's going to go something like that. Now, what is my asymptote? What didn't I cross? What line didn't we cross? -5. We didn't cross the -5. So I'm going to mark that in with my dotted line here. Mark in my asymptote. Marvelous. Now, here is an easy way to know where your asymptote is going to be. Notice how there's a -5 right there. That is how you know where your asymptote is going to be. It's either going to be your vertical shift or 0. So watch for your shifting, see how it moved. So my asymptote is y equals -5. My domain, all reals of course, and my range, just like last time, y is less than, hold on, not less than, silly. Greater than, right? Greater than -5? There we go. Almost messed up on that one. Last graph. So, very first thing, let's figure out x needs to be 0, so it's going to be in the middle. So, -2, -1, 1, and 2. If you plug in a -2, you get 26. Holy cow. -1, we get 6. 0 is 2. 1 is 1.2. and 2 is 1.04. Let's graph that puppy. So I have -1, 6, oop, there we go, 0, 2, 1, 1.2, and 2, 1.04. So we're going to looks like our graph goes something like that, right? What kind of graph is this? It's going down. It's decay because it's less than 1. Watch out for that. Okay? Asymptote. My vertical shift was a +1. So I'm going to have y equals 1. So I'm going to mark that into my graph here. With my color, I'm going to do, let's do yellow. So if I could find my yellow, there we go. There we go. So that's my asymptote marked in there all nicely. Range or domain, all reals. And your range, y needs to be greater than 1. Because notice, I'm hitting my y's greater than 1, not the ones less than 1. Be very careful, make sure it's greater than. Just some classifying here. Last thing we need to do. Just looking at the B's, you're going to look at the B's here, and that's going to tell you if you have a growth or decay. So if I have 1.2, it's bigger than 1. So you have a growth there. 0.3, that's smaller than 1, but bigger than 0. So you have decay. 3/5, that is 0.6. That is less than 1. So this is decay. And then this one, you're probably saying, well, that's decay, Miss Marsh. And I'm going to say, no. Just because it's a fraction does not mean it's decay. Think, 7/2. That is 3.5. That is definitely bigger than 1. So this is a growth. Be very careful. Don't just assume fractions equal decay. Make sure you take a look at that fraction first. Alright? That's the end of the video. See you later and have a good night.